So right now, as you are watching this video, your laptop is send a request to YouTube server. But how did it know like where to server is? There are literally billions of connected devices in the internet, and how did your request find the right server in the milliseconds? So the answer is the three things working together: an IP address, a DNS, and the port number. Already use all three every single days without realizing it. So as a Java developer, every time you write server.port equal to 8080 in your application.properties, you are already configuring one of these three things. So this is the day 3 of learning how to crack any system design interview from fresher to advanced level. So we'll be covering total 150 videos. So this is the third videos of that series. So let's start with the video. Before we go deep, let me give you the simple version of all three. Think of an server as an apartment building, and the IP address is the building street address like 142.250.80.46. So it tells you exactly which building to go to out of every billions of building on the earth. The port number is the flat number inside the buildings. The building has hundreds of flats. For example, flat H80 is the HTTP service, flat 443 is the HTTPS service, flat 8080 is where your Spring Boot application lives. The port tells you which flat and which specific services. And the DNS is the directory. You do not know the building street address, you just know the name. For example, the google.com. Then the DNS look up the name and gives you back the street addresses. So IP address, port, DNS, together they form a complete address of any devices on the internet. So let's go through each one properly. What is an IP address? An IP address is the unique number assigned to every devices connected to the internet. So every devices, every laptop, even your laptops, your phones, Google servers, Amazon server, all have an IP addresses. The versions you see most is the IPv4, the 4 numbers separated by dot. So each range between like 0 to 255, something like 192.168.1.1. So that is it. It's simple. But here is the problem. The IPv4 can only represent about 4.3 billions of unique addresses, and there are now more than 4.3 billions connected devices on the earth. So we ran out of IPv4 addresses. So that is why like IPv6 was created. It looks more complex, something like 2001 colon something colon something colon colon something, but it support 340 undecillion addresses. We will never run out of those addresses. So localhost is just a human friendly name for 127.0.0.1, which is your own machine loopback IP addresses. When you run the Spring Boot on your computers and call the localhost 8080, you literally calling your own machines, which is a server. Next is what is DNS. So you type google.com and your browser does not know like what IP address that map to. So it does a DNS lookup, a 4-step process to find the IP address. So in the step 1, your browser check its own cache. Have you visited google.com recently? If yes, it's remember the IP and skip everything else. And it is first. Step 2, if the browser does not know, it asks your operating systems. Your OS has its own DNS cache. It also check a file called the host file, a tiny local phone book on your machines. So on Linux or Mac, it is the file name is /etc/host. Step 3, it neither the browser nor the OS knows. The request goes to your ISP DNS resolver. This is the server your internet provider maintains. It searches further on your behalf. Step 4, the recursive resolver. eventually reaches the authoritative DNS server, the one that actually knows the real IP addresses for google.com. So it returned the IP. Let me open my terminal and let me type the nslookup. So if we do nslookup google.com, so on doing it, see that the server addresses, server, the address, the non-authoritative answers, and then the actual IP address of Google's DNS return. So this is the DNS resolutions happening in front of you. So every time you open a browser tab, this is what happens in the background. Sometimes when a website moves to a new server, it takes up to 24 hours or for everyone to see the new sites. That's called the DNS propagations. So let's move to our next concept, is a port. So now you know, like IP gets you the right server, but a server is not just one thing. A single server might be running web services, database, page service, and your Spring Boot application too, all at a single time. How does an incoming request know, like, which of these services to go to? That is what a port does. Think of the server as an apartment building. So every services in that building has a flat number called a port number. So port 80 is what HTTP web services lives. Port 443 is the HTTPS secure web services lives. For port 880 is where your Spring Boot application listening, and port 3306 is for the MySQL. So these are the port number every Java developer must know. I've already learned this and you are using in your application.properties file. Now let's understand, let me put all these three together, then what actually happens step by step when you type https google.com on your browsers. So in the step 1, you type https google.com, the browser sees the URL and knows it's need to find the server. The next is step 2 is the DNS lookup. The browser does not know the IP for google.com. It goes through the DNS resolution process we just now cover, right, and result 142.250.80.46. And the step 3, the port selection. The browser sees that HTTPS and automatically knows to use the port 443. If it was HTTP, and it should use the port 80. The protocol tells the browser which port to connect it to. In step 4, the TCP connection. The browser connected to 142.250.80.46 on the port 443. This is the full address, the IP plus the port. Then server is now reachable. Now the step 5, HTTP request is sent. So get request with HTTP version 1.1 over the TLS encrypted connections. The server received the request. Now the step 6, response comes back with status code 200, OK with the HTML or the JSON. This is the exact answers to the most commonly system design interview questions. What happens when you type an URL? The IP address, DNS port. Now you can't answer in details to your interviewer. Let me show you exactly where IP, DNS and the port appears in your Spring Boot code. So server.port equal to 8080. This is the port your Spring Boot server listen to. Changing it to 1990, if you want to run the two Spring Boot applications simultaneously, then each need to be have different port, because your have the same server which is your same local machine. Then you have server.address equal to 0.0.0. This is the IP address to bind to 0.0 means accept connection from any IP addresses. If you set to 127.0.0.1, only request from the localhost can reach to your application. So we usually do during our development phase. Then we have like Spring data source URL jdbc :mysql and this IP addresses with the port and the database name. Looking at this, the 192 dot something something is the IP address for the MySQL server, and 3306 is the port. So we know the server and we know the port, and the your Spring Boot app is using both the IP and the port to find the database. And every localhost is a DNS. So when you write JDBC MySQL localhost :3306, your operating system does a nslookup on the localhost and resolve it to 127.0.0. So DNS is always here, even locally. More question that comes up in the real system design interview. Let me give you the answer now. So question 1, the difference between IP addresses and the domain name. IP is the numeric machine addresses, domain is the human reachable name. So DNS map a domain to the IP. Question 2, what if the DNS goes down? The website become unreachable even if the server is running perfectly. The IP is fine, but the client cannot resolve the DNS. This is why the DNS have multiple redundant server. Question 3, how does localhost resolve to 127.0.0.1? So 127.0.0.1 is the loopback addresses. It routes back to your own machines. So localhost is just a DNS entry in your OS host files and map it to it. So no network needed. So questions 4, difference between port 80 and the port 43. The port 80 is HTTP unencrypted, and the port 443 is the HTTPS. So TLS encrypted. In the production, always use 443. Sending JWT token over the port 80 means anyone can read them. So to summarize, day 3, IP addresses gets you the right server. DNS translate the human friendly name to an IP. The port get you the right services on that server, and in the Spring Boot you configure all these 3 in every single day. So tomorrow, day 4, the HTTP deep dive, what we actually inside a request, we'll understand that header, body, status code, the full anatomy of the HTTP. If day 2 was about the restaurant, which we was talked in the last video, so day 4 is about what the waiter writes on the notepad. So subscribe to the channel so you will do not miss the upcoming videos. Drop a comment what port number surprised you most today. So see you tomorrow, and all the best for your interview.